space. So we'll keep that. Alright, we're going to do, did we get our temperature done? I don't think so. Keep it. We're going to do our EVA report. And we just went over our 29-minute mark. So welcome to Kerbal Space Program 1.8.1. We're going to take our EVA report. What we did is we just achieved space orbit for our last video. And I've just done all my space science as you were fading out or fading into this one. And while I'm out here, I'm going to collect it. And what we're doing is we're collecting our data to take it into the capsule for our safety. Dinner board. Okay, so if you want to see if you performed your mission task, you just look right here and you can see all of them are done. We orbited, we escaped, we launched, we gathered scientific data, and I'm not sure if we achieved that goal by transmitting back, but we would have when we land. So at this point, we've done everything we can. We're safely in space. All right. We're a little low on our electric charge, so I'm going to turn my pilot assist off. That's the only thing that costs me electricity. Now I can sit up here without burning any. All systems are off. With the pilot aboard. So anyway, so the next step we need to do is go back to Space Center. Now realize this is our first mission. We've just got 30 minutes into the game. I mean, I'm sorry, did I say the G word? It's edutainment simulation program. Shh, don't tell your parents, but we're learning and having fun at the same time. And if we call it a game, they might take it away from us. But if we're learning and having fun, then this can be schoolwork, especially if they restrict us in our gaming. This should not be restricted. This should be like being allowed to reading books. Well, in the context of what you're doing. If you're acting like a goofball, just blowing up ships to watch the pieces come apart, giggling and laughing and acting like a fool, maybe they need to step in. It's too much fun. If you're actually trying to achieve goals and run missions and learn things, no one should restrict it just based on their what we call perception of your activity. Everything in life is a series of choices. Your choices will affect you, good and bad. You make a choice, something happens. It doesn't necessarily have to be good or bad. It's just going to shape the path of your life. It's choices. Anyway, moving on. So what we've come back with is more money, by the way. And at that point, oops. I guess this is a good place to be. We can see our ship in orbit, right? And there it is. Click on him. See his apogee, see his perigee, or apoapsis, periapsis. And these little colorful things here, these are potential missions. So it looks like they want us, let's see, above, below, above, below, below. So these are airplane missions. This is a space mission, or you have to be able to fly an airplane really high, which you can't do at this phase yet. So they're wanting you to perform that from space. Even though if you do make a plane and can fly it that high, they'll give you credit, which is what I usually do anyway. You just have to attach a rocket to it, go over there and shoot up. It's kind of fun. Anyway. Okay, so this is a landing mission, which looks like it's not far from us, so they probably want us to roll down to that one in a rover craft. And that's a flyover mission. So it looks like what they're trying to do is get us to fly over the mountains, fly over the ocean. We have a secret base out here too, a secret military base. It's not that big of a secret because it's right there, called an island airfield. But I think it was secret at one time. You can fly over and land on that runway. It's good airplane practice. Oh, it's fun to take off from because it's basically you launch off a cliff. You don't even have to worry too much about your landing gear. You just fly off the edge. Actually, an airplane that doesn't really fly under normal conditions could launch off of that because of that launch space. Like too much fuel for your own good. You'd never lift off a normal runway, but if we throw you off a cliff and you lower your landing gear and point your nose down, you'll catch up to the physics before you die. Parents should definitely not stop that when you're learning so much about aviation when you even attempt that. And anyway, let's get out of here. I just tried to upgrade it. We're here by accident, burning time again. I'm talking about this program, entertaining myself. Okay, so we have enough money there. Let's go ahead and upgrade that one. Now, we eventually need to upgrade this one, but we can function there for now. Okay, so we have 74 to spend, which isn't a lot, but we can move really fast at this point. So, you know, this is the one I want right here. And that's so I can achieve near-Earth orbit later. And we'll come back, and this is the next one I want because it has a battery and a science experiment. And I want to fill in the middle. I'm a little short right now. Looks like I need 15 science points. So let's go get another mission. This basically says, okay, so you've got into orbit now, smarty pants. Let's see if you have enough fuel to bring us back. It's all funny. You can pause and read it if you want. At this point, we can accept 7 missions. So whether you want to accept any of those that we were looking at before, you may or may not. Those were the focused observational surveys, the atmospheric surveys, the observational near survey, and the focused temperature survey. Those are the ones I showed you on the other one. All these others are equipment tests or challenges to haul something. I don't like to do the equipment test because they always have very specific parameters. If you're going to do that, keep in mind that this is what you're doing, and this is really how to build your core value skills and maybe attempt some things that aren't so easy. Now, let's just look at this one because this is supposedly a complicated test. See, they want you... Okay, this is an easy one. This is test at the launch site. So you basically just go to the launch site before you take off, push a button. Let me see if I can find a better example of what I was trying to talk about. Okay, here's one. They want you to haul an R10 Hammer solid booster into flight above Kermit. No problem. You can just carry it as cargo if you wanted to. But the thing is testing it fires it. So what they want you to do is be between 23,000 meters and 26,000 meters. That's just so happens to be where the air gets heavy and you can tip your rocket. So what you would do in this one, come up, as soon as you hit heavier, tip your rocket, fire that thing, and you've done the test. It's going to actually help you. It's going to give you speed in the right direction, but here's the problem. You already got to be doing between 480, 550, between 23 and 26. Those numbers move fast, and if you're not right on them and have not engineered your craft to do exactly that, that's going to be more of an engineering problem than a piloting issue. Anyway, it's a lot of fun. But what happens is if you accept this test, you'll get caught holding it, then you have to decline it. There's a penalty, and they take money back away from you, and you lose reputation. Yeah, see, 4. You know, you need to be a man of your word or a Kerbal of your word. And by the way, man and woman is a synonymous switch, meaning if I say one, I mean the other. I'm talking about mankind or the human species, not the gender of man and woman. Man and woman together represent man to me, the general word, or mankind, or our species. It's just the way I talk, and my heart is pure. And I actually believe men and women have different strengths and weaknesses, and women are better at some things than men, like long-term consequential thinking. but they have a weak wrist, and men have big arms and strong wrist. But sometimes they're kind of short-sighted of the big picture, and they like to track moving objects and capture or kill them. I don't know if that's some instinctual or that's learned, but we're really good at it. And sometimes we need the other half to give us the big picture. You know, kind of help us push our buttons. Who should be in control? Probably neither. Together. Anyway, it's like I said, everyone should always stay in the middle. They shouldn't be on any end of extreme. And you should always be ready to adapt, change, and at all times keep your mind open and don't trust even your own memories and ideas, because they're not always accurate. And an open mind and a flexible heart is always the best way to be. Compassionate, not angry. Grateful, not greedy. And wise and not ignorant. So those are the best qualities and the best place to be. We're approaching on the 33-minute mark, so I'm moving back to our new mission, which we get to go back to this guy. Now, if this is the only video you've ever seen, you'll probably be okay. But one thing we're missing in terms of science now is EVA reports. If you see, I just recorded one above Kerbal's grasslands. I'm going to keep it in board. Oh yeah, let's board anyway. I didn't know I already had a grassland EVA. That was the space EVA that we took by accident. Now, if you look down here, or up here, we can actually see the light of a celestial body. See that right there? That's called our Minmus. And this is called our moon. And what you can't see is there's a big black planet right there. So if you can see, we have the curvature of the planet. I'm flying backwards now. We can see Minmus this way and the moon this way. Let's go ahead and look at those here. So if I look at the planet like this, I back up. Here's the moon, and here's Minmus. That's the little point light we're seeing. On our planet, we can see Mars and Venus with our naked eye. Okay? Very obvious. They're near the moon on the plate. And what I mean by the plate is everything kind of follows in this little thing together. And even we do. And we're even launched on the plate. When we launched at 90 degrees, that means like if they set us on top of each other. So everything, when we look at Mars and Venus, they're with the moon because they're all in the same platitude or plate. Platitude. What's that? That can be used socially as a word too. Something I said to please you. I think they call it stroking, which I don't like that one. But platitude. Sometimes it's just pleasant. A pleasant attitude is a platitude. Now, if it's an artificial platitude, then it comes off as insincerity, and now you have the opposite problem. You're just basically a little mouthy hypocrite. All right, so without getting into those big vocabulary words, let's not explore concepts or do rants. Let's just do another EVA report and see what happens. And we're doing them in the dark. Okay, so this is over the grasslands again. I'm not gonna worry about that one, but I am gonna watch this, and I am gonna accelerate the time, and then I'm gonna move us to, let's say, right here. And what I feel like here is I'm gonna be over the shores or the mountains or something. Now, these are called biomes, and these are biometric spaces. So I don't want that one. I'm just going to board again. That's the grasslands. Biometric areas by which we have labeled for study. And we've created names like shorelines, mountains, grasslands, highlands, water. And we found that different scientific conditions differ in these different biomes. And once again, I'm over the grasslands. I'm just trying to do this demo. It's driving me crazy right now. See me getting all stressed and anxious. I don't know if you can see it, but I really am, because I've tried to show you guys 3 times, and I feel like I'm over shoreline, but it's telling me I'm over grassland. So I'm getting frustrated. So let's go ahead and do another EVA report. Water. Okay. I just succeeded. So sometimes you can smile and hang on, and then when you succeed, it's okay. So I'm going to keep that experiment, and I'm going to board. See, it lets us in with that one without giving us a warning. I don't know why we didn't get shoreline. Because I know for a fact shores is one. Deserts, mountains, shores, highlands, grasslands, and water are the 3 ones you can get now. But I'm moving forward in the video. We're going to take a little less experience because we really only need 15 to move to the next phase. And if I wanted to try to get fancy, I might try to wipe one of these out with the gas I have, which we need to evaluate that, by the way. Liquid fuel. Alright, so let's turn this on. And so what we call these are our prograde and retrograde. Retrograde means we're facing backwards. If you've ever heard the term retroactive, it means to go backwards. And it looks like we're over here across from Kerbal. So what I'm going to do is basically give it a little gas. And you can see our periapsis changing. And when our apoapsis catches us, all this stuff will become fixed. So watch this. It catches us. Now that's down about 15. Alright, now that was a mistake. I just needed to show you something, and I realized I made a mistake and have gas to correct it. So I'm going to put that back to 50. Now you can see I'm doing the opposite and putting it back. And the fact that I caught my mistake early and corrected it used a lot less fuel than had I progressed towards it, which I may have met the point at which then I can no longer correct for my mistake, and based on my choices, activities, and the limitations or abundance of my resource, I can either have to be forced to be finite or be able to be a little bit lazy. So it's like I was telling you before, everything has everything to do with everything else. You need to be able to look at everything and go, wow, okay, I can do this, I can do that. This isn't a big deal, this is not. And you need that because sometimes you need the vocabulary. You need to understand the idea behind the word or the concept of the vocabulary. Then you need to have a little bit of experience using these concepts that you learned, practicing in simulation, role-playing, education, or actually doing it. It's all wonderful. Actually, all of them is the best if you can somehow mix those up in your experience base. And then you actually have to apply all this stuff, and which is the doing part, by the way, which is the most important part, by the way. So then you get to this point where you have what we call a contextual perspective. Some people call it experience, but if you don't apply yourself, you can have experience and still be dumb as a box of rocks. So intelligence is a matter of a drive, exposure, and memory retention. We do have some of what we call limitations of our own minds, which could be unlimited or limited. We never know, based on the need at hand. So basically, what I'm saying is experience isn't everything, but a contextual perspective, which is an analytical application, understanding, and passion preferably passion for the task at hand, will give you this contextual perspective, which now you become a champion. So we're going to come back here, and I'm going to speed up the time a little, and I'm going to get over the top of this impact crater. And we had an impact crater millions of years ago, and what it did is it shot a big hole into our planet and had a ripple effect, which caused the middle to come out and the ring to come out around it, and that's our impact crater. So at that point, I'm going to put it in retro. I'm going to drop my periapsis, perigee, periaptic approach, periation, my periation, which is the action of peripaces, a corrective periation. You can play with terms. Sometimes you don't say the right stuff, but you'll come out with some creative, funny stuff to say. Like space Shakespeare. Wouldn't that be cool? Shakespeare in space. Anyway, so one of you guys gots to do it. Gots to. That's bad English, by the way, if anyone's who is speaking English as a second language is listening. I was just having fun, being creative. Little pigeon, never hurt anyone. Alright, so we set it on 23, and we're doing a time check at 50. 29 and 29 is 58. We've got about an 8-minute video. So we can see what's happening once we set our periapsis at a certain point, and we're beyond our apoapsis and plunging toward it without any correction. Our actual periapsis is changing. It's not constant. Now, why is this, we ask? This is a very simple thing, because this big mass called our planet has gravity, and it's strong, and it's pulling us. If you don't know gravity, what you do is you take an object like this, and you say, I am Sir Isaac Newton, and I can write math formulas, and I'm amazed by this action. And you drop it. You didn't see it, but basically gravity pulled the coin down. And Sir Isaac Newton wasn't the first one to notice this effect, because gravity is not new information. Okay, Sir Isaac Newton's the first one that could explain it mathematically, so other people could understand and create a model. And he also got to create the scale by which we measure gravity. And since he was so arrogant and ignorant of the whole universe, he actually made our planet, where we are, gravity force of 1. So the whole universe is measured in our minds by relationship to our own gravity, which is ridiculous. But it is. So a gravitational force on Earth is 1.0. So everything is either less than or more than Earth on our scale. So anyway, I'm just talking about this stuff because what I'm basically waiting for is the gravity to pull us in. Now, what we have is speed. As the gravity pulls us in, you can see our speed is increasing, right? 2290. I'm going faster as the gravity's pulling me in. This is ridiculous. I don't want to go faster. I want to go slower. Do you know how fast 22 meters per second is? This is faster than a speeding bullet. So we're basically Superman, or we're better than Superman here, traveling faster than a speeding bullet. A bullet doesn't even travel half this fast. I don't know. Don't correct me, please. I believe a bullet travels at approximately, and do not hold me to any of this, about 700 miles per hour. You can do the conversion into meters per second. I could probably do it too. Let me see if we can use my handheld computer. How fast is 2,300 meters per second in miles per hour?
2,300 meters per second is equal to 5,144.953 miles per hour.
Okay, so at 700 miles per hour, that's a bullet. We're going 7 times faster. Now that's all going to change pretty quick. So we're flying at 5,000 miles per hour now. I have a scaled down universe 1/10 the size here. So we're not all real Earth properties. Like our gravitational force is the same, but our actual mass is smaller. And that's so we can cut the time frame down, get into space in minutes, not hours. Our burns could be much lower and slower. The concepts and steps will be the same, but they're going to be shorter durations. This is just to keep us interested. There is probably a slow grind game, and there's a real-world Kerbal program. I'm monitoring now to make sure my stuff doesn't overheat and blow up, by the way, because we're getting hot. You can see us spitting flame. Anyway, you may be able to see that as we have entered into, we're out of space now, we're in our thinnest air. If you're in an airplane, your gas burns different at levels, and some of the engines won't even burn above this level. And then you have to make a mixture adjustment here, and when you get up here, you're pretty much into the jet territory. You're also into the high flyers like spy planes and things of that nature. Now you can see that as we hit the thick air, it's force. Gravity is a relatively weak force compared to air and air pressure. I mean, you think gravity's everything. It can kill us if we fall too high. Don't get me wrong. All right, our mystery goo containers may explode on us. As long as our engine doesn't heat up, because I want to cut the gas to maybe try to pinpoint the accuracy of my landing later. If not, we'll just stage here. I'm also taking heat off my heat shield and coming in with a big giant metal gas tank and a big these engines are metal and they don't melt, so they're good metal. And if you can see this mountain range up here, our station's just beyond that. We're not going to make it to that, okay? It would have been an admirable goal, but see, where our landing point is actually pulling back towards us. But one thing I definitely don't want to do is hit the mountains. So I'm going to go ahead and do my stage now and nothing else. And I just threw off that gas tank and engine. I kept a little gas so I could use it, but we didn't need it. So now I just threw it off. And there's a reason for that. And that's because I know a little bit about where we're going and why we didn't want that weight to carry us into the mountain. Now we weigh less. Now that we weigh less, gravity doesn't pull on us so hard. And I've hit my mark at the 28 mark in 35 seconds. Gravity doesn't pull on us so hard. This is the end of my video, and I'm just going to finish without you and not go on to the next video. But hey, thanks everyone for watching. But gravity doesn't pull on us so hard, so now we're falling slower, and we're going to catch up, and our parachutes are going to make it. But hey, thanks for watching Kerbal Space Program 2.0 Paystacks. Pilot and space training experience, personal experience, also demonstration video, raw and real. Have a great day. And always, good luck to everyone.